Hello and welcome to my channel. In this video we are going to solve a competitive examination question which is a combination of circles, circle theorems and properties of triangles. In the above figure, BD is the diameter of the circle, AC is a tangent to the circle at point B, angle EDG is given as 50 degree and angle EGD is given as 70 degree. Calculate angle GEB and angle EAB. So let us try to understand the figure first. So here we can see that a circle is given and BD is given as the diameter of the circle. AC is a tangent to the circle touching at point B. Now we can see that two angles are given to us, that is angle EDG and angle EGD. Now we are supposed to find out the angle GEB, that is this angle, and angle EAB, that is this small angle. So let us begin by finding the angle DEG first from the triangle DEG. Now since DEG forms a triangle and in this triangle two angles are already been given, that is angle D is 50 degree and angle G is 70 degree, we can find out this missing angle DEG by using the angle sum property of a triangle. It states that all the angles of a triangle, when we add them together, we should get 180 degree. So to find out the angle DEG, we are going to subtract these two angles from 180 degree. So we have written here angle DEG is equal to 180 degree, that is the total angle, minus angle D which is 50 degree minus angle G which is 70 degree. Now this will give us the value of angle DEG as 60 degree. So let us write here 60 degree. Now here we need to find out the missing angle GEB, and for that let us consider a circle theorem, which is angle in a semicircle theorem. It states that angles formed by drawing lines from the ends of the diameter of a circle to its circumference always form a 90 degree angle. So you can see that I have drawn a circle over here and we have drawn a diameter AB passing through the center of the circle. Now according to this theorem, if we take the ends of the diameter AB, that is A and B, and draw an angle in the semicircle of the given circle this way, then it is always going to form a 90 degree angle in the semicircle. So it doesn't matter where you are going to draw in the semicircle this angle, it is always going to give you 90 degree. So for example, I am going to draw an angle over here taking the points A and B. So here as well it is going to form a 90 degree angle in the semicircle. So let us see how we can make use of this theorem to solve the example above. Now here it was given that BD is the diameter of a circle. So let me just highlight this diameter over here. And using the endpoints of this diameter, we can see that an angle is being made in the semicircle at point E, that is at this point, this way. So using the angles in the semicircle theorem, we can now say that the angle made at point E is 90 degree. Now we have already got the value of angle DEG as 60 degree and we know that the total angle DEB is 90 degree. So now it becomes very easy to find out the angle GEB, that is by subtracting the 60 degree from the 90 degree. So we get the value of angle GEB as 30 degree, that is 90 minus 60. Now once we have got the value of the first angle, that is GEB, let us focus on the angle EAB, that is this angle. And to find out this angle, we are going to make use of another circle theorem, which is angles in the same segment theorem. It states that angles in the same segment are equal. Now you can see that I have drawn a circle and there are 2 points on it, that is A and B. Now these 2 points divide the entire circle into 2 segments. One is this larger segment called as the major segment and one is the smaller segment called as the minor segment. Now using these 2 points, let me draw an angle in the major segment this way. Now using the same 2 points, I am going to draw multiple angles in the major segment. So maybe this way. So according to the theorem, the angles in the same segment are equal. So for example, if here we get an angle of 10 degree, then this angle at this point is also going to be 10 degree. And as well as over here, because all the 3 angles are made in the major segment. So let us see how we can make use of this theorem now. Now let us consider 2 points on the circle, B and G. Now these 2 points divide the entire circle into 2 segments. One is the smaller segment, that is the minor segment, and the other one is the major segment. Now using these 2 points, let us try to make some angles. So we can see that already an angle is made at point E using these 2 points, B and G. And again using the same 2 points, we are going to make an angle at point D. And as we can see, points E and D, or angles E and D, are made in the major segment. So if we have the angle BEG as 30 degree in the major segment, then angle BDG also becomes 30 degree. So this angle becomes 30 degree. Now remember, this total angle is 50. So out of that, 30 degree is gone for BDG. So this angle becomes 20 degree, making a total of 50 degree. But at the moment, we'll focus on 30 degree only. Now once we have got this angle, let us focus on the triangle DFG. Now here DFG again forms a triangle, and out of that we have 2 angles with us, that is 30 degree and 70 degree. So again using the angle sum property of a triangle, we can find out the angle DFG, that is 180 minus 30 and minus 70 degree will give us 80 degree. Now once we have found out this angle, angle DFG will be equal to angle AFB, that is vertically opposite angles, because these 2 are the intersecting lines. So here we are going to get the value of angle AFB as 80 degree as well, that is vertically opposite angles. Now once we have got this, let us make use of a final circle theorem, which is radius tangent theorem. Now according to the radius tangent theorem or the diameter tangent theorem, the radius or the diameter always makes a 90 degree angle with the tangent at the point of intersection. So here DB is our diameter and AC is the tangent, and B is the point of intersection between these 2. So here using the radius tangent theorem or diameter tangent theorem, we can say that angle DBA is going to be 90 degree. Now a final step. Let us consider the triangle AFB. Now since this is a right angled triangle, right angled at point B, we also have the value of angle F as 80 degree. We can easily find out the value of angle A by using angle sum property of a triangle. So here simply we need to subtract these 2 angles from 180 degree to get angle FAB or angle EAB. So here we have written angle FAB or angle EAB is equal to 180 degree minus 80 degree minus 90 degree. So this is going to give us the value of angle FAB or angle EAB as 10 degrees. So this is its value. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel, and thank you for watching.